Hello everyone, this is your professor Raja Al-Mukahal. I have been getting several emails from you guys about asking me about how to calculate the wavelength in this week's lab. I'm talking here about Module 2 lab wavelength and energy of the wave. So what I want to do in this short video, I want to show you how to do that very quickly. So the simulation, basically when you click on modules, where is my right here? When you click on module, you're going to come to this, and then there is the simulation right here. And then there is a certain setup that you have to go by, and that is you want to put it on oscillation. Let me stop it. And then you want it on fixed end, and the tension is high. The damping, I believe, is in the middle. And then the frequency at certain numbers that I think it is amplitude 0.5 and frequency 1.5, and then there is another one. So let me just, of course there are some other adjustment here. Of course you have a ruler, so if you click on that you will get a horizontal ruler and a vertical ruler. There is also a timer right there, so if you click on the timer, the time will go. Of course there we go. It will go only if the oscillation is running. You know what I mean? So anyway, and then you can reset it like that. And then also there is a reference line, just in case that you need that reference line to measure, some from a reference point, whatever. So those are basically all the adjustment that you need. Okay. So let me begin with something really simple. Let's say I'm going to put the amplitude at say 0.1, for example. Okay. And the frequency, let's say 0.8. Okay, these are not part of our lab. I just want to show you some demo here. 0.8. Okay, then I'm going to run the simulation like that. All right, everything else is the same, and there we go. So you'll have a very low, as you can see, very low oscillation, right? So however, the reason it's low, or part of the reason, is because the damping is in the middle. Okay, so if I put no zero damping, the amplitude will increase a little bit. See that? But the thing is, the damping does not affect the wavelength, and it does not affect the speed or the frequency. The damping only affects the amplitude. In other words, if I increase the damping, the amplitude is affected here, the amplitude of the wave, that is. Okay, the height of the wave is affected. If I increase it really high, as you can see, the height of the wave, you could barely see it. But no damping, as you can see, the amplitude, which is the height of the wave. In other words, how far is the crest from this reference line right here? That's the amplitude, the maximum vertical displacement. Okay, so, but the wavelength is the same. In other words, if I ask you, or if I ask me, what is the wavelength of this wave right here? This is a standing wave, right? What's the wavelength of it? Well, simple. Here's how you do it. What you do is you, here we go, pick it up. Okay, so there we go. Right now, what I want to do, I can just stop it. Let me do it again. Stop it at maximum right there. There we go. Okay. So what is the wavelength? The wavelength is the length of one oscillation. So you start from one point, you end at the same point. Okay. So I'm starting from here, and I will end right here, and that's basically the length of a wavelength. The wavelength is basically includes a trough and a crest. So start from here, and it ends right there. So this is the wavelength of this wave, this particular wave. So how do I measure it? Just go take the ruler. Take that thing, we can ignore this vertical one, put it on 0 right there, see that? And then you measure the length of the wave right here, which is roughly, I believe, about 7.5, okay? So the wavelength of this one is 7.5, you got it? Okay, now let's try another number. Again, like I said, the damping here, whether you put it on half, right in the middle, a lot, it does not affect the wavelength. You still get the same number. All right, let's put another frequency. This time I'm going to put a frequency of 1.48. I purposely don't want to give you the numbers that are in the lab, so I'm going to give you something similar to it. There we go, and an amplitude of 0.59, okay? Sorry guys, my stupid phone is running. Uh, 0.59. There we go. Okay. Now I'm going to run the simulation. It's going to look a little bit different. There we go. So it goes crazy like that. Okay. The reason it's going crazy like that, it's not really a standing wave. There is some distortion, as you can see. It's because there is no damping. So let's say I'm asked to find the wavelength. Well, how do I measure the wavelength of this thing? Well, how about if I increase the damping? Remember, the damping does not affect the wavelength. So I'm going to increase the damping until I get a nice wave. There we go. See, it's becoming nicer. Looks better. Just like that. And all I need to do is you stop it at some point. It's like taking a screenshot right there. There we go. Okay. So now I want to measure the wavelength. Well, how do I measure the wavelength? One way to measure the wavelength is from trough to trough or from crest to crest. Here is the crest, which is the highest point reached by the wave vertically, to the next point where it's reached, by the highest point, which is right here. So basically what I could do, I could measure the crest, which is basically from the highest point here to the highest point here. That number from roughly 0 to 4, I'm not being precise here, but roughly from 0 to 4 centimeters that is the wavelength of this wave. Simple enough? So now I know the wavelength in centimeters. I know what the frequency is. You can find the velocity, correct? The velocity is what? The product of the frequency times the wavelength. There we go. This is how you do it. One more setup and then I will finish this video. Suppose I have the frequency to be 2.26. 2.26. 2.26, come on. There we go, roughly. And the frequency of 0.76. Okay, again, these numbers are just, I picked them in random. There we go. And then I'm going to run the simulation. And there we go. As you can see, it's going crazy. All I need to do is to stop it. There we go. And then I can measure the wavelength from here to here, from peak to peak, crest to crest, or from trough to trough if you want, from trough, from the lowest point to the lowest point. You're going to get the same answer. It doesn't matter. Okay. So that's basically how you measure the wavelength. Once you know the wavelength, you know the frequency, you multiply by each other, you will get the velocity. That's all you need to do, really. You got it? I hope this is clear. If you have any question, please write me back. Bye-bye.